Hello. Am I doing the intro today?
Oh, was I supposed to do it? Sure, I'll do the intro then.
Okay.
Hello, everyone, and
Shocked
welcome.
you.
Okay, take two.
Yeah, take two, exactly. Let's roll again. Hello, everyone, and welcome to another episode of Solving Advent of Code in Rust, and, well, learning Rust by doing so. Thanks, everyone, for following along. I'm Eugene.
Luciano?
Roberto.
We have them around here. I don't know who is where. If you never did Advent of Code, this is basically a coding challenge that is published every year in December. There are 24 challenges in total from the 1st of December up to Christmas. We are currently working on last year's coding challenges. You can find them on adventofcode.com. So we publish all of our code on GitHub, and I think we're getting a banner. Yeah, there it is. Wonderful. So we're publishing all of our code on GitHub. You're welcome to check it out. It's all open source, so go check out what's there. PRs are very well accepted, comments and everything else. Now, we have a YouTube channel as well where we publish all of the recordings of this. You can find the link in the description on the Twitch channel. Also, for those of you watching on YouTube, we also have a Twitch channel, so you can find that in the description of the YouTube below. Now, last time we were dealing with exercise number 18, which is basically solving some interesting arithmetic. But I think I'm going to let Luciano do that. We also got a PR for that one, which we should be talking through.
Yeah, I want to share the PR first from Tommaso. So, Tommaso, if you're watching, thank you. And basically, the idea, let me try to make this a little bit more readable, is that I don't know if it's worth discussing our solution very briefly, but let's see.
Our solution was basically going through all the operands, all the stuff in the string, and when there were parentheses, we were searching for the respective closing brackets, round brackets, and we were passing to ourselves in recursion a new string containing only the substring in the parentheses. Then going on with what we got back as as right operand of the operation we were doing, and continuing with our accumulator and operation on top of it.
It might be worth, for context, for anyone who's joining in now and doesn't know what the problem at hand actually was. Essentially, we're given as a string some simple arithmetic. It's basically addition, multiplication, and parentheses. And the idea was to solve them. Parentheses have priority. Addition and multiplication have no ranking, so they're solved left to right. And that's basically what we were solving before in the way Roberto just described.
So just to have a visual clue, I'm going to share another screen. Sorry about that. But this is basically the type of expressions we were trying to solve, one every line. And our solution is simply going character by character using these char indices. And basically at that point, we start to accumulate the values and do operations. And as Roberto was saying, when we find parentheses, we recurse into the solver function by sending a slice of the string that we identified being like the specific nested parenthesis. So the first nested parenthesis we find the matching closing bracket, and we recurse on that sub-expression. And I think what we were trying to say, Roberto, correct me if I'm wrong, is that here we are collecting all this information, and Tommaso instead was suggesting a solution that uses an iterator instead, rather than collecting everything up front, right?
Yeah, basically, it's passing the items around instead of allocating it. Because when you slice the string, you pass to this function in recursion the string, and from the string you are getting again items. Then if you find out, there is the recursive call. So every time you pass to yourself the string, there is an operation that makes the string in a stream of character that you consume. The pull request is basically changing what we take in input, and we don't take a string anymore, but we take, if you go back to the pull request.
Yes, sorry, I need to switch. It's going to take me a second.
Take your time.
Changing window is hard. There you go.
If you see now the inner eval is taking an iterator of character.
Mm-hmm.
So instead of taking the string, it's taking the iterator, because basically when we do the slicing of the subarray, of the substring, we are giving to ourselves this string, creating a new iterator, and then using the value out of it. But in that way, we are not we are getting rid of values of this iterator. So we are creating multiple iterators when one is enough. Because another stuff that changed in this pull request is that when you find a closed bracket, you return the accumulator. Because think of this: if you are in an expression and you open brackets, so you call recursively yourself with another iterator that starts from the value after the brackets, at one point you will find a closed bracket that is not the closed bracket, because you go recursion every time you open a bracket, but one day we'll find a closed brackets because expressions are always valid. When you find a closed bracket, you mean that what you have in your current recursive call in the accumulator is the result of that couple of parentheses. Then you give back to the recursive call above that at that point use that value as his operand, do his operation with the accumulator. And if you find another closed bracket, what you have in the accumulator at that point in that recursive call got passed to the previous call again, and like this for all the level of parentheses. So you have one recursive call for every open parenthesis. And you can work with only one iterator that is created once in a function that I think is a little bit below.
Yeah, which is here, right? Eval.
Yeah, that eval is a wrapper that is often common when you have to do this kind of stuff with recursion, that is converting the string to the iterator the first time, and then calling and returning the function that is doing the recursion. That is that one.
Mm-hmm.
So this is a little wrapper just to change the type.
So you could imagine that eval is like our public interface, and this inner eval is just an internal abstraction to use the iterator, basically.
Yes.
Recursively.
And also the code is simplifying because, like we said, when we close the bracket, we just return. Done.
Which
and when we open, and when we open the brackets, instead of doing all the find the closing brackets and so on, if you scroll a little bit, we can see the added lines.
Mm-hmm.
It's just saying, okay, the right side is the inner value of the iterator, that is from where I'm now to go on until the matching closed brackets, and then apply the operation between the accumulator and the right operand.
Mm-hmm.
Recursion do the magic of matching parentheses, basically. So even the code is way less, and I think it's also faster, because in this way the operation of doing string.chars is only did once without the collect, because there is no collect here, instead of being done every time there is an open brackets like we were doing, because when we were slicing the string, we were going back in eval again, and eval was again doing the char synthesis and collect. So
I think this one, yes. So basically this one was recreating a vector of indices for every substring.
For every recursive call, exactly. And this was time consuming and also memory consuming.
Do we want to run the benchmarks on this?
If you look at the PR, the pull request, sorry. PR pull request, okay, sorry. There are already benchmark and valgrind. Okay, when you run benchmark on the go to 18 part 1, because those are, it run benchmark for everything. So
there you go.
Yeah, 80% faster here. But watch out, when you run this kind of benchmarks in GitHub, you run in a virtual machine in the cloud on Azure. So it's not sure that when you do the first run and the second run and you compare the result, you were running in the same hardware strictly and with the same CPU. So that number is telling us is faster, but the true number that is really telling us is faster is the valgrind test. That is the other comment. That is the one above this one, I think. Yeah, that one. 71% faster, so you see it's slightly different. And this is the number of instructions, assembly instruction run by the virtual CPU. So this solution is way faster.
It's doing less things at least.
Yeah, it's doing less things and faster, even on virtual environments, so with a lot of noise. So in my opinion, is way better.
Okay, so I will say we merge it and we continue with part 2, right?
Yes.
So I'm gonna approve, and thank you again, Tommaso, for this amazing PR. Please keep doing it. I think you are winning beers and other prizes.
When we can go to a pub.
Exactly. Okay, perfect. So I'm gonna stop sharing at this point. And Eugen, if you want to take over.
Of course, let me share my screen. And we're, geez, let me find it. There we go.
Do we want to explain part 2 before, or do we want to code it directly?
We could explain it with the tablet. We can try to do that.
Okay, I'll stop sharing then. Not that it's visible.
So let me see if it works. It should. Let's see. Sorry, today lots of screen sharing.
Yeah. Also, I'll get myself a tablet as well so I can do this as well.
Okay, so do we want to explain? So the idea now is that those expressions in the first part of the exercise, there was a particular rule that is different from normal math, which is basically the operators have a different precedence. So multiplication doesn't come before addition. But whatever you see first on the left side, you just resolve it. So if you see, for instance, something like, I don't know, 2 plus 5 multiplied 3, in regular math, you would solve this first, and then you solve the addition. In part 1, it was required to us to implement this in a different way. So you resolve the first operation first, and then you resolve the other. Now, part 2 is basically telling us that there is now precedence of operators, but it is the inverse of real maths. So addition always comes first. And we need to implement a solver that will solve the expressions by respecting this rule. So
we are going for a simple solution even this time, so we can take pull requests for more complex one, or we can do that later if we have time.
Okay, so Roberto, do you want to try to explain, and I'm going to try to draw, but I think we want to start without parentheses, right?
Yeah. We start with an expression without parentheses, just to explain the idea.
Let's keep this one on a side for now, and let's just say, I don't know, 2 plus 3 multiplied 2. Is that good enough?
Do another plus at the end, maybe.
Or put a number before it.
Before what? The plus?
Before the 2.
The first 2 or the last 2?
The first 2, sorry, you have 2 of them, Mr. Before the first 2, sorry. Put a 4.
4 plus or multiplied?
4 multiplied. Okay, 4 multiplied 2 plus 3 multiplied 2. In normal math, they have a precedence. Here they have the opposite one. So we have to do 2 plus 3, that is 5. And then we have to multiply by 4 and 2. And we get 40. I don't know, probably. So the idea here, we start with a string. So the idea is very simple, very stupid. The idea is that we do a split on star.
So that basically will mean that we split here and we split here. So we end up with 1, 2, and 3, right?
Exactly. We have a vector of strings with those 3 strings on it. Then on this vector of strings, we split on plus, and we come out with a vector of strings. But at this point, the string will have no operator in them because.
So at this point, let me try to visualize it. So we have something like 4, 2 plus 3, and 2, and
After
those
the
are
first
all strings, then the next step will be that for every one of the strings we split on plus. So
Yeah.
this will become an array of arrays where this is just 4 because there is no plus.
And so
This one
it's
will become 2 and 3 because we split on plus. And then we have another array that is just 2 because there is no plus inside, right?
Yeah. Now we think that we also casted everything to integer here because okay, we can do that. At that point, on the inner element, we map on the inner element, also on the inner array, we do a sum that is the highest priority operation. So sum of 4 is 4.
So basically, this will become 4. This will become 5 because we are summing all the elements, and this will become 2.
Exactly.
So this is literally map sum, basically. Let's call it this way for now.
Okay. And this one is map prod. When you have this out,
and at this point we do map prod.
And we have a number out of this.
And this basically will multiply.
This is a reduce, but well, okay, you understood me. Basically, we have to multiply all the numbers together. I think in Rust is just dot prod and
dot product. I think you have, yeah.
Product. So, okay, fine.
Yeah. So this will be 40 at the end, 40. Right?
Yeah. In this way, you address the precedence of operator. That is the wrong one, and I always mix stuff when I do this because I want to do the real work in math, and then I remember that I have to do the other way around. Now that we know how to do this, let's keep this in our mind and park it a moment. We go with parentheses. That is making our problem harder.
Let's see if we can clean up.
Luciano fighting with the iPad.
Okay, ready. Sorry.
So here the idea is like the one for part 1. So we go in recursion. We look at pieces without parentheses inside. We do recursion on top of them. We replace the piece with the solution, and we go on until we solve. We have an expression without parentheses that we can solve, and we have the final solution. How to do this? Okay, this is inefficient. We are locating strings. Don't judge us. Judge us, but later.
Do it with a PR.
Yeah, exactly. You take the string, you search for the first closing bracket. In our example, is the one after the 2. If you go...
So this one.
No, the first closing parenthesis.
So the first closing will be this one, right?
Yeah, exactly. Is that one. Then you have that pointer is like 7. I don't know. I'm throwing an index at random. Then you search for the first opening brackets going left from 7. So, for example, in Python, there is a function called rfind that is finding from the right. So you go left and you find the equivalent opening brackets. Doing this, you have 2 pointers in the string. You are sure that there are no parentheses in those 2 pointers. And you call yourself with just this 3x2. 3x2 with the algorithm from before is looking, there are no parentheses, cool, so I don't have to do any kind of recursion. Is doing split, prod, sum, everything else, returning a number. The previous call of myself is getting back this number and is putting it back into the string in the place of what he found. So now we have a new string that is 2 plus 6 plus open bracket 2 by 4 closed 2 brackets. And this is a new string. At this point, we return ourselves solving this new expression. That will again find the first closing brackets. There are closing brackets, yes, okay. So find the previous open one.
So this one,
yeah. Then finding
and then this one, and of course this will become 2 plus 6 plus 8.
Exactly.
Right?
Then you call again yourself with this new expression that will be, okay, find that, and you have 2 plus 14. And again, you have no parentheses in this one, so you know that you can just solve it directly, and this is 16. So, what is not good in this solution is allocating strings, replacing in strings, and passing strings that then they are parsed. Okay, is allocating a lot. Then you are putting numbers back in strings. Is a little bit messy, to be honest, but I think is working. So we can implement this. Then we can move to something fancier if we have time.
Yep, and I see we already got a suggestion of a possible algorithm to have a look at. I have no idea what that does, but something maybe to research and maybe try to implement for the next time.
Okay.
It's reverse Polish notation, basically, as far as I know, anyway. So what we were discussing before, which we may do in a future episode. I don't think we'll have time for that today.
If we have time today, we can try to do part 1 with
Roberta, you're muted, I think.
Hello?
I can hear you.
Okay, can you hear me?
Can't hear you.
I can.
Oh.
Okay, Luciano can, so I will go on talking. I was saying, if we have time, we can do RPN for the part 1. It is simpler because there is no priority, and then we can obviously be more complicated with priorities. But well, Eugene, are you sharing the editor?
Clicking around now.
Cool.
Using computers is very difficult, you know. I shared it, and I'm also going to do 2 clicks of zoom. Let me know if it looks okay and it's readable.
Do another one, just in case.
Okay.
Or Luciano, do you want to put the full screen?
We can also try to go. So I just discovered this, by the way. Computers are amazing.
Okay,
so
cool.
we can go full screen if it's if it makes
better?
it more readable. Yeah.
For
Okay,
me,
cool.
fine.
I can also close this thing in some way, but I'm really not sure how.
You can even drag it. Yeah.
Cool,
Just drag
done.
it.
Wonderful.
I think it's Control B, by the way, but
Yeah, you're right. Okay, sorry. I am not familiar with this editor, although I should be, I guess. All right, so basically we have part 2. What do you think we should start with?
we can create an eval2.
Okay.
Did you pull, by the way, that
I
other
should
solution?
have. Oh no, I didn't pull after the thing. Let me just do that really quick.
Is it that unreadable if we keep it this way? Just so we can
For
show
me-
ourselves talking.
Okay, so you can move the hands and people can understand what I'm saying.
Okay, don't save. Sorry, this is really fun.
I have to prepare puppets to
To explain.
Puppets, yeah.
to explain algorithms.
Okay. So eval2, maybe.
Naming is hard.
It is. We'll name it something pretty later. Okay, what do we want to do with this one? Do we want to solve the math with priority bit first, or do we want to...
Okay, we can go taking a string.
Okay.
A string on str, but well, we will figure out when Rust is complaining about types.
We'll call it an str for now, and it will return something. Whoops. It'll return a U64, let's say?
Yeah, U64 for now.
Because we don't really know sizes for any of this stuff.
I think we fit in a U64, I hope.
Okay.
Okay.
So
let's do the stuff without parentheses, then we write a test to test without parentheses, and then we add parentheses.
So let's call this... how do we do math with priority? Just to know exactly what it does, right? Precedence, whatever. It returns 0. Okay, so for each...
By the way,
Does it have
str, you
splits?
need to put an ampersand before it. Needs to be like a reference to
You're
str.
correct.
And this will be a single line because we are splitting the line in part.
Can I?
The part two.
So we want to split it by plus, then by star, I guess, right?
Not by star, then by plus again.
Because it's the reverse, of course.
Yeah, because it's the reverse.
Can you chain this? I don't think you can, right?
So you get an iterator there. It's like split doesn't automatically allocate. It just gives you an iterator that as you go, as you say next, is gonna give you the next.
But we need to split the inner bits.
Can we map and split again?
Can we do? Oh, or we can map. Yeah. Okay.
I think you can map. Yeah. I don't know if you have to do .iter or you can map directly. Yeah, you can map directly.
Seems happy. Okay, so expression, and we're going to split by plus.
Okay, what we can do here is even better. We can split by plus.
Mm-hmm.
On the split, we chain a map again. So dot map. To cast to int, Luciano, if I want to just do the map to make the string.
You need to do parse.
Parse. But you have to say
map
that you parse.
But I need to tell it.
No, use an X like as a.
Yeah.
Sorry, I think you need to. So you need to put the pipe around the arguments in both expression and X, like if they were parentheses. Correct. Yeah.
You are correct. Apologies.
That's no problem. And now you can say X dot parse column. No, sorry, before parentheses, I think.
Yeah, specify the type.
Oh,
yeah,
okay.
I think you are forced to say the type.
I guess.
Yeah, in angular brackets.
Yep. Sorry, I'm still finding my way around.
And now that might work.
I think
you might need to unwrap.
Let's just lists vectors. Maybe if I collect,
you'll see exactly the type. Yeah, and I think you get results because we are not.
Map of split.
Oh, it's not showing the entire type.
It's
because you also need to collect inside the other split.
Yeah. Wait, no. This is the.
Okay. Wait.
I'm collecting this, but I'm not closing this bracket.
Please wait.
Okay.
Don't collect anything. Remove the collects.
Okay.
Listen. After the dot map with the parse, when the round brackets of the map is closing, the dot sum.
Dot and wrap.
No, well, I want to sum what is inside that iterator that comes from map.
Seems to be.
I think you'll need to do dot and wrap inside that X parse.
So under parse.
Yeah.
Oh, on wrap.
Okay.
Okay. Now
on the closing round brackets of the first map. So dot prod.
Product maybe.
Product. What is the why you want a U34? I hope he wants a U64. What we have back from here, I hope, is a U64.
It doesn't know.
Okay, follow if I did something wrong. Try to put this on multiple lines. Every time you open a bracket, go on a new line.
Yeah.
Or every dot, for instance.
Can I do this? No.
You can put. You can do that, I think.
Okay. What I'm thinking is the first string is splitted on star. It gives us an array of strings, a vector of string, an iterator of strings. Sorry, I can't use the right words. For each of these strings, we are again splitting on plus and mapping them to numbers with the parse. Then we are summing the one that we splitted on plus. And we are making the product of the one that we splitted on star. So in the end of all of this, this will be a number. Try to...
U64, let's see.
Is he happy with that? No, he's complaining about
Type
something.
annotations. Oh, like give this. Wait.
He's not able to infer what? What is B?
Map B.
Is the output type. So it's not able to infer that the output type is an iterator of numbers.
Of this map.
Yeah, that map, that map ends with a sum. He's not able to infer that the sum is giving back a U64. How can we tell him that that map is giving back a U64? He was suggesting something like put the sum and in the angular brackets U64.
Oh yeah, you can probably do that. So if you do sum colon before the parenthesis, and then U64.
So he's not able to understand that if we parse U64, we want back U64.
Turbo fish.
Feeding the
At that point,
fish.
we can return that expression that is already our.
Yep. How about we write a test for this thing?
Yeah, well, let's write a test for this guy.
Okay. Ooh, test eval, cool. How do I hash? Like this, yeah. Sorry, func test, do math with priority. I'm sure there's a better name for this.
We are going to rename it probably, but
yeah, sorry. It's quick, it's dirty, and it works, which is what we care about. Okay, which one do we want to try?
Let's try 2 plus 3 multiplied 9 and 2, yeah. And, and we know that this one must be 45.
We didn't remove spaces, right? We should have removed spaces.
We did not, you're right.
But let's see if it works first. We can
we parse the integer. If there is a space, is going to complain, or
let's see.
I think so, but I mean, let's see.
Whip.
What is this?
Select the queue not used.
Well, fine, later.
Okay, so this worked. With one warning for not using this anymore. Okay, that's fine.
Let's try also to do 9 multiplied 2 plus 3. So you just move the 9 in front, multiply 2 plus 3, and you remove there.
Okay,
that this must be again 45 because the priority is.
Add some spaces here so we can actually read this.
And let's see if spaces are parsed.
That's a good question. Failed.
We have to strip.
Wait.
Trim. Sorry.
Where is the
exception?
Yeah.
I probably have the spaces. Unwrap error. Yeah. Panicked on the unwrap.
Invalid digit. Okay, so
but we have spaces in our input, so we have to just do a trim when we do the parse, before doing the parse, sorry.
Yeah, but do we want to do that at this level? As in do math with priority?
Yeah, I think is the right place because the function of it is only going at... no, we can't just trim. There is no trim.
Trim usually takes the ones at the ends, though, right?
On both sides.
No, both sides. You have like trim end and trim start.
Trim normally
or trim does both sides, but you should do it before parse.
Inside the parse.
So you do
trim.parse.
Yeah.
Yep. If I put another dot. Okay, let's see if this works. Where's the?
Or we can replace all the spaces with nothing, but
no, this is fine. It works.
We will look into benchmarks when we have something working.
Is this also supposed to be 45?
Yeah, because the precedence is always on top of the plus.
Oh yeah, you're right.
Instead, if we are doing that with part 1, you're doing 9 multiplied 2, 18 plus 3, 21. So completely different result. So That function is doing its job. Cool. Let's care about parentheses now.
Let's call it just math with priority. Sorry, I hate having really long names for things.
But also we can do everything in one function, and I can explain why.
Yeah,
So,
okay.
When you enter in the function, the first check that you have to do is there is a closed parenthesis. So
Yeah.
how you
Find,
do that
I guess.
Input.find, no idea.
Yeah. So it takes a pattern, but I guess we can give it, can you give it a character like this? But I'm not sure if this is going to find the first. Yeah, first character. The byte index.
And if is giving you an option, so if there is nothing, it's giving you none. We have to match.
So if some, I guess.
No, I'm fine with. We have to do something. If there is nothing, that is what we already wrote. And if we find something, we do have to do something else that we are going to write. So,
but you called the structure ready with if let some.
Right, that's what I wanted to do.
Okay.
If let some, if I remember the syntax for this thing, I think we have
it's like some I or some X, whatever you want to call the value.
Equals this thing, right?
Exactly, yeah.
I always forgot that we can do this. And in the else, you put what we have now.
Sorry.
That probably we have to precede it with a return.
I think so.
Because now we will have multiple point of return.
By the way, were we using 4 spaces or 2 spaces?
For what?
For the indentation here.
Use whatever your editor does. We can do cargo FMT at the end.
Oh yeah, that's going to fix it. And we should probably make this look a bit more normal. Anyway, sorry, for this thing now.
Now, if we found a closed brackets, we have to find the open one with before that one. So up to that position, we have to find the rightmost open brackets. So it's possible to do input and a slice until I. So what is square brackets? No, it's a square bracket.
Oh, it's the square brackets, and then you go
dot I. I'm throwing random stuff in.
I don't think that's how you do that.
Yeah, I think we already tried this in the previous episode.
And it failed pretty badly.
And there is the issue with Unicode that Rust tries to guarantee that you never break Unicode characters. So you cannot just slice arbitrarily into strings. Unless there is maybe some method that will give you like a result or something that you can unwrap. Maybe there is, so we can do a quick research on that.
So if on top of that you do dot something is not working. Okay. My God, why so difficult? What are you?
I suppose because it's something that might panic or give you like unexpected results. So I'm quite sure that there is some helper functionality to do that, but will give you like a result that you should handle.
So I use sides. What we described that we are going to do is taking input up to that character. So we take a substring of that string. Try to see if on input there is something like find instead of just find.
Okay, let's.
Find? No.
Yeah. There was an find. Returns the byte index for the first character of the rightmost match.
The rightmost, yeah. This is what.
That's the one we want.
Yes, but we want it on a substring. That is up to I.
So let me give it opening bracket.
Yeah, but up to I. So, and at this point we have this problem with the slice.
Yeah.
But
if anybody in the chat is smarter than us and knows this, this is your time to shine.
It can't be so hard to slice a string on a position in Rust. It's impossible. This is so hard.
Yeah, because they reason in terms of like Unicode characters more than bytes.
But make me slice on Unicode character. I'm fine. Give me the ability to slice a string.
No, I'm sure there is. I'm just trying to figure out what is the right method. I haven't found it yet.
Okay, I'll Google around as well.
Okay, let me think if there is an alternative approach. Because previously we made the character slice and we worked on that.
Can you try again to do
Do what?
that square brackets?
But was it .i? No.
Yeah.
It seems happy with this.
Okay, so maybe it actually works.
Okay.
Let J be that number.
Yeah.
Oh, gives you an option because refined gives you an option.
Yeah, unwrap it because we know that our expressions are always good. I mean, they can't be wrong.
So now we need to math with priority again.
The number priority with the substring that go from J to
I,
but
right?
without the parenthesis, the dot, J dot I.
Oh, sorry. Yes.
But we have to not take the parenthesis. So it's J plus 1.
J plus 1, I minus 1.
No, if we don't use the equal, I is already excluded.
Yeah,
correct.
So I it's fine.
Sorry, you're right.
And J plus 1, we have to put it in brackets, or is fine, and they understand that we want J plus 1 too.
No, J plus 1 is included.
Yeah, but we have to put it in brackets or not. I mean,
let's just do it.
Yeah, I think so.
Because I don't know if he knows. Now we lack a semicolon at the end of that line.
Yeah, but
and we put this inside a variable called something.
Result, yeah.
Sub-result. This is a sub-result.
Yeah, correct.
Now we have a 64 sub-result. We have to return ourself. And now here I'm telling what I want. Then we look how to write it because I don't know. That is the string up to J. So input up to J excluded. So dot J.
Dot J, yeah.
How do you concatenate string in Rust?
Plus sub-result, I guess, as string.
As a string. You would like if it is a
sub-result. Yeah, you could probably use format.
Well, let's write it, then we do.
So this thing is very unhappy with this. Oh, reference. Okay. Oh no, wait.
Okay, so format, cool. Let's go.
Wait. So let's fix this before. Mismatch types. Expected a reference to a string and found a string instead.
Oh, try to put the ampersand in front of input.
Okay. Now it's unhappy cast to use size.
Big Luciano was saying that we need format to convert the
yeah.
to, and we can do all this new string with the format.
So format is a macro, so you need to write format, ! open parenthesis.
Yeah, but we can do that for everything, even for the first piece.
This.
Yeah. So format. Then we have 3 parameter in the format.
Yeah.
But you need to define the format string first. So
yeah, that is with the curly brackets.
Curly brackets for every placeholder. So you
make
it a string.
So.
And we have 3 placeholders.
Sorry, yeah.
So 3 curly brackets, yeah.
And then I presume.
The first one is the input. The central one is the sub-result, and the right one is input from I plus 1 going on.
Let's put this in parentheses. This is remarkably unreadable.
Yeah, sorry. And you put a semicolon at the end of all this stuff if we...
No, because it's returning.
No, but you need it because you are explicitly calling return.
Yeah, I can... because it's on an if, you're right.
Probably we can do this with a match. If we do it with a match, it's becoming an expression, so okay, later. Now what is complaining about?
Oh, you probably need an ampersand in front of format, and I expect lifetime fun.
No, the size for values of type str cannot be known at compilation time.
So
Okay, remove it again. Let's see the previous error.
I think it's the same, or yeah.
Assign that format to a variable just to see what we get out of it.
Yeah.
So
yeah,
let's call it new input or something like that.
New input, new expression, new something. Okay, he's not happy with that format.
Yeah.
That is a string.
Oh, again, try to put ampersand input everywhere.
Ah.
I don't know why it works in line 70, by the way.
And
okay. So this needs to be an
as ref. No, as ref, I think.
It seems happy with it this way though.
Okay, that's good. I was expecting some lifetime fun, but that's good.
Okay.
Wait, we're not out of the woods yet. Can I move this into part 2?
No, because part 2 has to call that. Look at line 64. Copy line 64. Line 64.
Right. Yeah. Oh, we need
Copy
this.
line.
Yeah,
Yeah,
okay.
because we have to do this for every line of the input. So
you are absolutely correct. I forgot.
and
Apologies.
now the function is not a eval anymore, but is math with priority, and so it will also be happy that we are using. And you remove in line 83.
Yeah, I'll remove the underscore.
Yeah, because now we are using the variable. If we did everything correct, it's going to work.
I'm gonna run the test because I'm that confident it's not gonna work. Let's see.
Yay!
But it worked.
Ooh. Okay.
Nice.
Work.
Remove that vecdq, please.
Yes, it's a bit annoying.
Probably we need this for the RPN notation, but that means
later. We don't need it yet. Okay, if I run it again, that warning should be gone, right? Hooray! It is gone.
Run. Open a terminal in VS Code.
How do you open a terminal in VS Code?
Control backquote or Control Shift backquote, one of the two. Or
Control,
if you are Shift backquote or Control backquote, Command Shift backquote.
Nope. Sorry. Backquote is the backtick thing.
Yeah.
Yeah, the one on the side of one. At least on a USA keyboard.
It's next to Shift. Jesus. Terminal. I don't know what that means.
Okay.
Anyway, we have a terminal now.
Terminal, thank you. Go in the year 2000, exactly, exercise 18. You can run a cargo bench from here.
Before that, can you do a cargo FMT?
Yes. Thank you very much, Luciano.
Let's see if it did fix that expression. I'm curious. That nested stuff.
Wait. Oh, yeah.
Yeah, a little bit better, yeah. Okay, cool.
Not amazing, but it's better. Much better than what we had anyway. Let's cargo bench it, and then I would commit because this is a fully functional solution.
Yes.
And it's our first attempt, so
yes,
good to have it there. It's gonna take a little while.
So in the end, what we can do, if we want to refine this solution, before doing the RPN for part 1, if we want, is that if we let sum can be a match, probably, Luciano?
I don't know if that's any better.
I suppose. It could be because then we don't need to return.
Exactly, like because a match is returning. The if is returning and the else is returning. So they are both returning.
Okay, so let me commit this stuff.
Yes.
Okay, solution, maybe first solution. For Y 2020, X 18, part 2. Cool. So now to make this into a match, so we can go match. Can I do it on this directly?
Yeah, input find, exactly. And now the first case is sum I. And you do the arrow, fat arrow, not the semicolon. Remove the semicolon.
Sorry. And now I put the code block and I put this stuff
Exactly, and you can remove the return from there, basically.
Yep. Okay.
And now comma at the end of that. I think you need a comma there, and then underscore, yeah, and arrow.
And you don't need the curly bracket, I think, because it's just an expression.
Not sure. You can probably avoid that. Yeah, you're right.
This bracket here.
Yeah, and
the
also the semicolon at the end.
On 82.
Oh yeah, you're right. Doesn't seem. It is happy. Okay.
Now give it another cargo FMT to see what
How
it does.
did I? Man, this does not actually. Sorry. This does not actually open a terminal. It cycles through my editors, which is pretty terrible.
To me, it's control backtick, yeah.
No, control, not command. You're okay.
Yep. So it's just the character above.
Wait. Cargo FMT error. Am I not? Holy shit! Sorry. Oh, I was in the wrong terminal. Yeah, apologies.
Okay, did something.
Command line editors have the advantage of I don't have to be an idiot with them.
I don't know if performances are better or not. I don't think it's changing anything performance-wise.
Let's run the test first, see if it still actually does the thing. Although I could have run cargo test. Okay, it still works. And now
I was hoping for it to work again.
Let's see cargo bench. I don't think it's going to be...
After 18 exercises, at least we learned the match statement.
Yeah, we got something. I also learned the let sum.
And also the chaining of map, type, parse, unwrap, prod,
Yeah.
and all the guys.
I think we have an unhealthy like for the unwrap thing. Because in real-world applications, I don't think we should be doing that.
Yeah, I think when you use it, it will be better rather than using a wrap to use expect, I think it's called, where you can pass a string that says this is an integer. So if there is an error, you will see the error saying, oh, it did fail in a place where you assumed this was an integer, something like that.
Yeah, exactly. And if it
it's
was
a little
real
bit
world,
more descriptive error message.
Exactly. And if it was real world, it would also be a bit more defensive than all this.
Yeah, but in a real world scenario, if you do an API, you have a layer of validation in front of your business logic often.
True as well.
So you can say that your business logic doesn't have to do another layer of validation because you have a layer of validation in front of your business logic. True, that is always better to have it, because if you release your business logic as a library, then who is using your library can do.
Yeah.
I suppose if this was a library, our eval or the other function will return a result, and then any case where you could fail, you immediately return an error variant of that result saying this is the error.
There was an error in the expression, error, go home, you are drunk.
No, that's fair enough. Okay. Anything else that you guys think we can do to this?
I don't know. We are very close to the 1 hour mark. So maybe if there is something small, we can...
That's why I'm asking.
Yeah.
So the only stuff that I think of going on with is doing RPN for part 1, but in 10 minutes, I don't think we can.
No.
Oh, yeah. There was a suggestion from Amperl saying something like this. Let me put it on screen.
Yeah.
You'll be trimming a lot of times if you do it after the internal number of substrings.
I suppose at this point to remove the spaces.
So basically, wait, what? Replace the whole input. Yeah, exactly. So let me find that.
We can do that in the part 2 function before mapping with priority.
But where is the trim? Because I don't see it anymore.
Is on line 78.
Jesus, sorry. Yes. Okay, so basically here.
Yeah, before that map, we can do another map.
Even before lines, I guess.
On
Because
the
we can
Woolly
literally replace the whole thing, right?
on the Woolly input, but lines.
Dot lines. Would that not work?
Yes, but
It could work. Let's try.
Like it's one replace for
yeah,
the
no,
whole.
I was thinking, is that one is going to allocate a new string?
Maybe. We can run the benchmark after if you want. Okay,
Yeah.
the test's passed. Let's see if it's any slower.
I hope it's faster.
Nah.
Are you
You
in
are
the right
running all
folder?
the benchmarks.
Okay.
Yeah.
You are in the wrong folder.
Apologies, I am not the...
It's Monday. We are tired.
I've been doing
Yeah,
IKEA
yeah.
boxes all weekend, that's why. IKEA furniture, sorry. Which was in boxes. Okay.
Take it easy. He's
Warming
doing
up.
part 1, warming up part 1, then he's doing part 2. Take it easy.
Yeah, sorry, I'm gonna stop rushing.
You see, when you just do cargo bench, even if your machine is an hardware machine, you have a big delta in performances.
Yep.
Probably we have to add a makefile with a Valgrind. I'm not sure that is true that we regressed, because we regressed also part 1 and we didn't touch it.
I can do it again, see how much variation there is. Now, I might have a lot of stuff running on this machine as well, which may be spiky, so I don't know.
Yeah, part 1 improved. We didn't touch it.
Yeah, 5% even. So we have so far 20% margin of error.
Yeah, no, but what I was saying, cargo bench, even if you have a physical machine,
yeah,
now we have no change in performances. But well, in any case.
But this will be the change from the latest execution, right? Or does it do an hash of the source code?
No, it just keep the previous run.
Okay.
Compare you with the previous run. It's not doing.
I can stash this then.
You can stash bench, stash pop, and bench again, and hope that your machine is stable in the meantime.
Fingers crossed.
Otherwise, by next time, I will add, or somebody will add to the makefile. Well, a makefile with a Valgrind command. The only problem is that I don't have a Mac, and Valgrind is, I think, a little bit peaky on the kernel.
Okay. We can try either Luciano or myself then, but then it won't work for you, so I don't know.
Or instead of doing a commit here, you cut a PR from where you are now. At that point, GitHub will run Valgrind for us.
Yeah, we can also do it. Oh, I was thinking about the Valgrind idea. We can also run it in a container, which can be.
But the container is still running in your.
Oh, it's still running in your machine. You're right.
In Mac is a virtual machine or is using the Mac kernel? I don't know on S6 how it works.
I don't know.
Well, in any case, guys, performances seems not to be changing.
No, wait. I need to put the stash back on.
Okay, sorry.
Now we'll get the actual difference, if any.
Okay, if your machine is stable.
If. We'll see.
Yeah, sorry, I was missing the step.
Meanwhile, I'm going to check the documentation of replace just to see what it does.
Yeah.
Well,
I don't know.
Probably is allocating a new str.
That's why people join our stream, to hear us make weird noises.
It's not a noise, it's a type. It's str.
Correct. Now, to me, it makes the most sense to do the replace before we actually split it by lines or do anything else. Because it is a global operation, right?
Yeah, you get a new string, basically. a big string.
Yeah, if the input is not huge, you can do that on the Woolly input. If the input was 1 terabyte, you have to do this after the split lines, because
we can map it if you want. Let's try that as well.
I'm fine. Say that is slower. It makes no sense to be slower, in my opinion, but
I don't know. So map L with the other pipe, L pipe.
L dot replace.
Okay, and now let's see what this is doing. Apologies.
Oh.
What? What's the problem?
That replace is giving back a string? No.
Yeah, I don't think you can call map.
It's not giving back an str, it's giving back a string. So our mat with priority is taking an str, not a string as input. We are converting the str to a string, but then we have to change everything in cascading in our implementation.
Okay, just put it at the very top and leave it.
Yeah, we are fine. It was a joke. Because string has lines as a method, because lines probably is on all the string-like object.
Actually,
right, and lines will give you strs.
And lines will
because they are views inside that string, basically.
Yes.
Yep. Replace empty spaces before splitting input by line. Push. Cool.
So did we validate that it was faster or not in the end?
It didn't show me any difference.
No, not a relevant change.
So why don't we keep the trim approach? I know you just committed it, but I think
I can always revert. I mean,
leave it like that. You know what? Leave it like that. We can,
because now the tests are gonna fail, right?
Why?
For map with priority.
I don't think so. No,
map with priority. Run all the tests.
Another test.
This one.
Yeah, that one is going to fail because of white spaces.
Yeah, you're correct.
You can remove the white spaces from the string or get rid of the test, because we...
Well, we know it works, but it is
remove the test. But I was just considering which doesn't matter because in terms of... Sorry, go ahead.
I was going to say I wouldn't delete the test because we used it to get here, and I guess it illustrates what the function does.
Okay.
Not that it's not clear. Again, I know this isn't real work, and it doesn't.
Cargo test before committing, and for today we are done. You are in the folder, okay? No, before
I am in the folder.
Yeah, no, sorry. Before running all the testing, because they start to be a lot.
Yeah. Commit AM.
You know what? We can post a pull request that put back the trim where it was. At that point, GitHub will run Valgrind, and we will have the real answer to: is it faster or is it slower?
Remove. Sorry, typing is difficult. Okay, cool. So that's that has been pushed. Cool. So I suppose we'll wrap it up here then, right? You can find the recording of this on YouTube. The link is on our Twitch in the About section for the YouTube channel. If you're watching this on YouTube, we live stream on Twitch every Monday, 5 p.m. UTC, which is currently 6 p.m. Ireland time. Anyway, make sure you check the Twitch link in the YouTube description and give us a follow so you can be notified whenever we put something new out. Feel free to leave us comments or open PRs on the code. Luciano can put a little banner maybe of where we store this code on GitHub.
Yes. If I can find it.
You'll find it. No rush.
Give me a sec. I was already looking for rating, but go ahead.
Cool.
I have to prepare the cardboards with the links.
Yeah, just lift them up one by one. Cool. So the code is there on GitHub. Feel free to put comments on there or open PRs if you have better options or interesting options for changing things. Everything's very well accepted. We are trying to learn Rust, so don't expect any of these solutions to be the cleanest, the most idiomatic, or the best in any way. If you know better ways, let us know, like I said before. Thank you all for the suggestions and collaboration in the chat. That was really good. We're going to raid someone, and thank you, goodbye, and see you next time.
Bye.
Bye.
Raid in 5 seconds, so you need to tell a joke.
4,
Standing
3,
by.
2.
Bye, bye, bye.
Tell a joke for 5 whole seconds.
Done. Bye.